Hello everyone, let us now discuss the GFT POTD question, trapping rainwater. This is the same as LeetCode question number 42, a hard question, trapping rainwater. Now, here if I so if you didn't know about the question, you are given with an array which contains the height of a building or a block or a wall. Now, you need to count the number of units or the number of units of water which can be trapped in between these buildings or these walls. Now, it is the same as the question building and water. Now, the amount of water which can be trapped should be written as the answer. So, if you take this example, then this is the amount of water it can be trapped. So here it is not trapped. Here if you see, it is not trapped because there is no building to the left of this index. So if I take with the correct example from building from 2 then going to the next level. So stick on to this video. Let us find out what is. So here you can trap the rainwater till here, right? Here you can trap the rainwater of 2 units. Now, if you see here, the size of this building is 2 and the size of this building is 3 and the amount of rainwater that you have trapped is 2. So here you got 2. Here you got 2 as the answer. So 2 is the output for this example. Now, let us go through the another example. Now, I need to find out what is the amount of water that can be trapped here at this index. That means in this place, what is the amount of water that can I trap? If I go through the previous example, you got this left as 2 and the right as 3, and I may say this one no. If you take like this, it is wrong because you can trap the rainwater till here, till this margin. So at this index, only this index, as I said, only this index, I can trap the rainwater till 3. So what am I searching for? Am I searching for the previous or the next index? No, no, right. I am not searching for it. I am just searching for, if you see clearly, this is the height of 4 and this is the height of 3. But here you got the height of 2 here and you got the height of 3 here. But as there are only 2 buildings adjacent or after this index and the previous index, so it's easy to find out. But here to this left, the tallest building, I am considering the tallest building, which is 4. To the left, it is 4. And to the right, I got this 3, which is tallest. And from these two, 4 and 3, I am taking the minimum. I am taking the minimum out of it. And it is 3. So, let me wait and change this building blocks. Now, you got this building blocks here. Imagine you got another block here. So the size is just what is the number you can trap? Just 2 units, or you can trap 2 because this building is having the size of 1. So you cannot do that. You cannot trap in this building. So when I got any building at this index, you got this building. Now at this building we have the minimum trapping size as 3 and remove this size. minus 1. So remove the size minus 1 and you will get the output as 2. So this is how you solve this problem. You just need the left tallest building and the right tallest building. That's what you need. So if you want, you can draw something like this. Now let me take an example. So here there is a tallest building and here it is some a medium building or a smallest building, and here I got another building and here I got another building. So if you see clearly at this index, if you see clearly, the amount of water that can be trapped is not only till here, it is still here because all this amount of water can be trapped. So our intuition is to find out the amount of water that can be trapped at every index. Now come to this index. So at this index I am taking the tallest tower to my left and to my right. So what is the tallest tower to my left? It is this one, and the tallest tower to the right, it is this one. So use the same algorithm here and here. So let us now count the number of units of water that I can trap. So initially I come to this index. Now there is no building which is tallest, or there is no building to my left. So here I can trap 0 units of water. I am coming to this index. Now the tallest to the left is nothing, and so I cannot trap any water here, so 0 here. Now I come to this index. The tallest building to my left is having the size of 1. The tallest building to my right is having the size of 3. Now, what is the minimum of both? Here it is 1. That means I can trap 1 unit of water. So, I am coming to this index. 1 minute. The tallest building to my right, 1 minute. The tallest building to my right is, if I come to the next index, the tallest building till here. So here I got the tallest building. Here it is 2. Now as it is the tallest, there is no building tallest to the left. So if even if it is 1, we cannot trap the water at this index. So it is 0. Then coming to the next index. So here you got the tallest to the left is having the size of the building, or the height of the building is 2, and the topest building is having the height of 3. So minimum from these two is 2, but I am removing 1 because the size of the current index building is 1. So 2 minus 1, yes, we can store 1 here, 1 unit of water here. So the same thing 2 and 3, but here I can store 2 units of water. Now coming to the next index, here I can store the left it is 3 and the right it is 3, the same, the size, sorry, the height is 1. Now I can store 1 element of water. So I come to this index, but the left is having, there is no greater than the current index, which is top than the current building. Now here I cannot store any water, so it is 0. I come to this index. Now the toppest to the left is 3 and the toppest to the right is 2. But here I cannot store any water because there is nothing greater than this index. So there is nothing greater than the current index height. So the minimum from 3 and 2 is 2 itself, right? To the right, I have this 2 and also this 2. And to the right, the tallest building is having the size of 2. Now, the current building is also having the size of 2. So, it will not store any water. So, I am coming to the next index. Now, it is having the size which, so the leftmost tallest building is having the size of 2. The right tallest building is having the size of 2. Now, the minimum from these two is 2 and I will remove 1 from it. Then I will get an output of 1. So, here I can store 1 unit of water. So, let me count what are the number of elements or units of water that I can store. Initially, it is 0. Now, 1, 2, 3, 4, 5 and 6. So I can store 6 units of water and I will return this output. So how can I write the algorithm? The first thing, or if I start with the intuition, so intuition is 1 minute. Intuition is to find the right right topest building and left topest building, and that's it. If you have the topest building of the left and also the right, to the left and right at every index, and you can find the amount of water that you can store at or trap at this index. So amount of water trapped. So how can you calculate the amount of water trapped? It is the maximum of 0 and because let me say why it is 0. So 0 and minimum of largest to the left and largest to the right. That's it. So why I am taking 0 here? So when I get to this index, here you got 2 right, here you got 2, and if I remove 2 from 2 it will be 0, and if I got any index or the minimum of the left and right, here you got 3. The minimum to the left and minimum to the right will be 2 right. Now, in this case, instead of storing 2, here you got 0. If you see clearly, here you got 0. Now, that's the thing. Why? If the height of the building is greater than the leftmost and the rightmost, then you will store 0. So, minimum of largest to the left and largest to the right minus height of current index. So if I remove 3 from 2, you will get to the negative value -1. So that's why I'll be storing 0 instead of -1. That means I cannot trap water at that index. So if you want to write the code, then you can go and skip this video here itself. But if you want algorithm or code, then stick on to this video. So let me write the algorithm here itself. 1 minute. Algorithm n will be initialized and left maxi and right maxi initialized with int minimum. 1 minute is also initialized with int minimum, and now there will be two arrays left and right of size n comma 0. So here it will be storing the left building height, which is topest, and the right building size, which is the topest. Now for I is equal to 0 to n, I'll be iterating and left is equal to, sorry, left maxi, the maximum building size to the left of current index. So left maxi is left, sorry, maxi comma height of I, and left of I will be left maxi. Then iterate from the end. Now for coming for initializing the right array, I will be coming from I is equal to n minus 1 to 0. Right maxi is equal to maximum of right maxi comma height of I, and right of I is equal to right, sorry, maxi. Then after initializing this left maxi and right maxi, it is simple that for I, sorry, I is equal to 0 to n, iterate over every index of height. Now answer or water trapped will be, first let me initialize the water is equal to 0, and water that can be trapped is maximum of 0 comma minimum of left of I comma right of I minus height of I. So by removing this height from the minimum of left and right, then if you get positive, you'll be getting sorry, adding to the answer. If not, it will be 0, right? So let me return water. That's it. So this is the code initializing left maxi with int main and right maxi with int main. Now left and right. So this is the same code will be used for the trapping rainwater. Now you have array instead of left, sorry, height. So let me change it. Control A C. So let me change here, instead of array I will change it the name. Let me save it. 1 minute. Sorry, here I have made a mistake. Maximum of 0 comma minimum of left of I comma right of I minus, sorry, height of I. So sorry, minus height of I. So here it is the code for this. Now let me use this here. So if you like this video, share it to your friends and subscribe to my channel. And if you have any feedback or suggestions, please comment in this comment section. Thank you.